Okay, so since we talked about finding the sum of a geometric sequence, now we have to use the summation notation to find the sum of the series. The sum of the series. So let's see how this works. I'll do the first one, and it looks easy, but it's kind of tricky, so that's why I want to show you number one. Then you could try number two, which is more idea. And then I just want to warn you, number three is quite tricky. So kind of brace yourself. So let me do number one. So we have a sum here. So here we have the sum from I equals 0 to 6. 0 to 6 of 4 times quantity 3 over 2 to the I power. So the lower limit is at 0 and the upper limit is at 6. So how many total series are we talking about? It's not 6. Remember? It's 1, 0, 1, 2, 3, 4, 5, 6. So in fact we have 1, 2, 3, 4, 5, 6, 7. We have a total of 7 in a series. If we were to put the 0, the lower limit of 0, where the I is. So let's start this way. The first term of the series, a sub 1, is given as 4 times the common ratio of 3 over 2 raised to an I power 0. And any exponent raised to a 0, you know it's going to become a 1. So that's simply a 4. And that becomes the first. Now we could find the sum of the entire series using the summation notation, given the lower limit of 0 and the upper limit of 6. And we know we're going to have a total of 7 terms here. So that's something to think about. Alright, so here we have S of n is equal to the first term of the series, a sub 1, times 1 minus the common ratio r to an n power over 1 minus dr. And now we're going to find out we have a total of 7 in a series. 7 in a series. So we go S of 7 is equal to, of that 7 terms in a series, the first one is valued at 4 times 1 minus the common ratio of 3 over 2 raised to an r power, or n power I mean, over 1 minus the 3 over 2. So you could see right away, 1 minus 3 over 2, that's kind of like saying 2 over 2 minus 3 over 2, which is negative 1/2. So we go 4 divided by the denominator, negative 1/2. That's like saying negative 2 times 4, which is negative 8. And we know that there's a total of 7 in a series. So we're going to go 1 minus 3 over 2 raised to a 7th power. And let's go and evaluate that exponent. So we have negative 8 times 1 minus. So we use our calculator and say 3 raised to 7th power. We have 2187 over 2 raised to a 7th power. That's going to give us 128. And isn't 1 minus 21 over 7 over 128 kind of like saying 128 over 128 minus 2187 over 128? Common denominator. And so when we go 128 minus 2187, we end up with a negative number of negative 2059 over 128. And let's simplify. The coefficient negative 8, I hope it reduces 128. So let's find out. 128, is it divisible by 8? Yes, it goes in 16 times exactly. So that's going to be negative 2059 over negative 16. And I hope that's divisible. Let's see. 2059 divided by 16. We get some decimal number, 128.6875. 128.6875. And it's a positive value. Or you could just say, 128.69 if you like. Okay? But that's the total sum. If you were to add total of 7 terms in this series, starting with the lower limit of 0 up to 6. Alright? Now, you try number 2. Alright. So you said, okay, now that you got me a little confused with this 7-term thing, don't worry, check this out. The lower limit of this one, it says here, the sum from I equals 1 to 10 of this given general form. So if the upper limit is 10 minus the lower limit is 1, that's 9 plus what we did not count. So there is only 10 terms here, so that's no problem. And when we put that I1 in here, that's going to become a 0. So in fact, this follows the general term. The initial number of this series is 8. And the common ratio is 3/4. So now we could use the S of n is equal to a sub 1 times 1 minus r to the n power over 1 minus dr. So now, how many total terms are there? In this case, there are 10 total terms. So S of 10 is equals to the initial number of 8 times 1 minus the common ratio r, which is 3/4, raised to, and how many total number are there? Yeah, there's 10, okay? All raised to 1 over 3/4. So now let's evaluate the denominator. For me, that works easier. 1 minus 3/4, that's like saying 4/4 minus 3/4, which is simply 1/4. And this becomes a quotient within this quotient, so 8 times 4 is 32. Times 1 minus, well, now we have to evaluate the exponent, so 3 raised to the 10th power. It says 59,049. 59,049. All raised to 4 raised to a 10th power. That's going to be 1048576. 1048576. And let's go and evaluate this. Isn't 1 minus this mess just like saying 1048576 minus this number? The numerators? So let's go and do that. 59049. That gives me 989527. So that's 32 times 989527 over 1048576. Now I'm hoping that the coefficient 32 reduces this denominator by some whole number. Okay, so let's figure it out. Does 1048576, is that going to be divisible by that 32 coefficient? My calculator says yes, it goes in 32,768 times. So that's 989527 divided by 32768 times. And when I evaluate that, what do you mean by that is, go ahead and do the division. 989527 divided by 32768. That gives me some real number of approximately 30.1979. So let's just say 30.198. That's going to be the value if we were to plug in from the series 1 all the way to 10 into this general rule. Okay? Give yourself a pat on the back if you got that right or close to it. Now this is the real spicy one. Try that one. Okay. This is it. So you said, alright, now you really got me confused with, again, the lower limit of 0. I thought it was 0 to 6 meant there were 6 terms, but it turns out since we start with a 0, there are 7 terms here. This one, since we start from 1 to 10, there are 10 terms here. So how many terms do we have here cumulatively? So here's how it's done. You take the upper limit minus the lower limit, and that's going to be a 6. But wait, since usually when we count, we start from the beginning 1. See, as we step off, we count 1, but we usually don't count what we're on. Okay? So we have to always add 1 extra. So the total number of terms we have here is actually 7 terms. Yeah, you have to keep that in mind. When we're counting object, you don't count off, you start with that one. Okay? So we go, alright then, S of n is equal to a sub 1 times 1 minus r raised to n over 1 minus dr. Now we're looking for a total of 7 terms, so that's going to be S of 7 is equal to, what's the first term? Is it 6? Like that? No, no, no. It is not. What you have to do is actually put that 8 and substitute it into that I. Okay? So what happens is then what you get is 6 times 2 raised to 7 minus 1, which is 6. And so that's like saying 6 times 2, well, let's see, 2 raised to 6 power, that's going to be 64. Whoa, 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 wait a minute. Why am I putting a 7 here? It starts with an 8. So when you put an 8, 8 minus 1 is 7. So sorry, that's a 7. Okay? So 2 raised to a 7 power. Whew, almost went the wrong way on that one. That's going to be 128. There we go. And so 6 times 128, it's going to give me 768. So the initial value is going to be 768. Now we go 1 minus the r, common ratio, which is 2. That one is given. And the n, again, there's 7 terms. See, that's where I get confused. 7 terms. All raised to 1 minus the common ratio of 2. There we go. Now we're going. And now let's simplify some things here. So we go 768, the outside coefficient, okay, times, that's 1 minus 2 to the 7, and I almost made us, well, here we have it. 2 to the 7th, that's 128 already anyway. So we got 1 minus 128 over 1 minus 2 is negative 1. So we could keep on going and say that 768 times 1 minus 128 is negative 127 over negative 1. Which is simply saying 768 times positive 127. And all we have to do is multiply that two numbers. So we got 768 times 127. So it turns out, if we start adding the series from the 8th position and take that and substitute it into the I and evaluate into that general rule, and we take that and add it to the next of the series, all the way up to the 14th, just that portion, those 7 terms will add up to be 97,536. Something to think about, huh? All right. Good luck.